Okay, so moving into Unit 5, Lesson 3, we're going to look at quadratic inequalities and how to express those solutions. We haven't done a ton with inequalities in terms of graphs, but I just wanted to do some nonlinear ones, as everything else is kind of a prerequisite. So we're going to consider the function here, f of x is equal to x squared minus 1, which is shown right here in the graph. Okay, we're looking for boundary points, which is where the function is greater than 0 and then where it is less than 0. So boundary points, again, are where the graph goes from above the x-axis, where it's greater than 0, to below the x-axis, where it's less than 0, excuse me. So we find those boundary points where it's jumping back and forth. You find the boundary points by finding the zeros, or by solving for x. All right, so set the quadratic to 0 and solve, and you'll know where those 0 values are. So looking at what I mean by that. So we have a function here, 3x squared plus 4x minus 4. The first thing you need to do is identify where the function is equal to 0. So what are the x-intercepts? We have one here at -2. And at about 2/3. And now you guys will actually solve for that. But just for the purposes of this, I want to just show you what we're talking about here. So f of x is equal to 0 when x is equal to -2 and 2/3. Okay? So we want to know for what intervals is it then less than 0? So if we look at our graph, it dips below the x-axis, and down here is less than 0. It dips below after -2 and jumps back above after the 2/3. Okay, so the interval for being below, if it's coming down here and then going back up there, is from -2 to 2/3. Now, why do you think we use parentheses? So we're using parentheses because this says less than 0, not equal to 0. And so at those points, it is actually equal to 0. Okay, so to solve a quadratic inequality, write the inequality in the form f of x is less than 0 or f of x is greater than 0. Solve for your x-intercepts so that you can find your boundary points. Where is it going to cross over? Divide the number line with your boundary points and then pick a test x value in each and plug it into f of x. Record whether you get a positive or a negative. Okay, you'll go back to step 1, and if you have negative pieces, it's less than 0. If you have positive, then it's greater than 0, and that'll tell you where that interval is. So again, noting when to use brackets, when to use parentheses in terms of whether or not we're looking for greater than or equal to, or just greater than or less than. Okay, so using the 3x squared plus 4x minus 4, which was one of the examples we did with just a regular quadratic, we want to graph the solution set and state the solution using interval notation. So the first thing we need to do is factor this if possible, or use quadratic formula or something to find our x-intercepts. So this one actually factors into That's 3x and x to give us 3x squared, and I'm going to try 2 and 2 to give me the 4. That's 3 and 4, or that's, excuse me, 6 and 6x and 2x. I want plus 6x minus 2x to give me plus 4. And so there's my factors. That's less than 0. I'm just going to set each of those equal to 0 to find my x-intercepts. So ignoring the inequality just for a second, and setting each of those factors equal to 0. So x is equal to 2 over 3, and x is equal to negative 2, which is where I got those values earlier from that graph. Okay. So these are your boundary points. What we're going to do with that is we're going to look at negative 2. We have a 0 here, and then 2/3. We're going to look at these different intervals of our graphs on either side of our boundary point, and we're going to see what signs we get. And so essentially you're making a table. You pick a point in the middle. I'm just going to pick 0 because it's easiest to plug in. And then maybe I'll pick negative 3 that's on the left side, and let's color code these. And then let's do, I don't know, even just something like 1 would be on the right of that boundary point right there. Okay, so if I plug in a negative 3 and solve, okay, so if I plug my values in, I get 11, negative 4, and 3. And the values really aren't important. What's important is that with negative 3, I got a positive. With the 0, I got a negative. And with the 1, I got a positive. And so we want to shade from here to here. Why? Oh, excuse me. Okay, why are we going to shade here? All right. And so that's the question you need to answer. And it has to do with the fact that this inequality is less than 0, and less than 0 are negative numbers. And so that's where we're shaded, and then that's our interval to answer this question. And we're going to use parentheses because it is less than. So we have negative 2 to 2/3, which is the interval we talked about on the very first page. Okay, so moving into, I do want to reiterate that this has nothing to do with if you were to graph this in a coordinate grid. You would have your, well, actually, hold on, let's back up. You've already have it graphed. Well, your x-intercept at negative 2. And like 2/3. And then there's a vertex at, there was a vertex somewhere down here by negative 5. This is on the previous. And our y-intercept at negative 4. So we have something like this. And actually, I just drew that wrong. This would be a dashed line because it says less than. And because y is greater than, if we plug our y back in here, y is greater than that entire function, we're going to shade above the curve. So we would shade in here. And that doesn't have anything to do with what we're talking about here when we're talking about when is the function itself below or less than 0. So that's looking for, at this line, when is it below that line? Okay, so from what interval to what interval? So we're looking at two different things here in terms of when to shade and what I'm talking about shading here on just a number line. Okay. All right, so let's run through a couple more examples real quick. Here, get it set to 0 first. So we get 12x squared, and I'm just moving everything to the left to make my x squared positive, minus 3x minus 9 is less than or equal to 0. These all have a 3 in common, so you could just reduce this real quick. So 4x squared minus x minus 3 is less than or equal to 0. This one actually factors, and I know I'm not spending time like going back through how to factor this, but this factors as 4x plus 3, and then x minus 1 is less than or equal to 0. So 4x plus 3 is equal to 0, then x is equal to negative 3/4. And if x minus 1 equals 0, then x is equal to 1. And so in terms of our number line, we have solid circles at both negative 3/4 and 1. So again, we need to know what are those values when we plug in to our equation. Well, if we plug in a negative 3/4, plug in like a negative 1, something past the 3/4, so that's 12 plus 3 is 15 minus 9 is a positive value. Plug in like 0, something in between your two values. So that gives us a negative 9 if we plug in 0, so that's a negative value. And then plug in something greater than 1. Plugging in 2 gives us 48 minus 6 minus 9. That's going to be a positive value. And so I didn't even really notice. I just did kind of some math in my head there to determine that, those values and if they're positive or negative. We're once again, in this case, going to shade where that negative interval is. And that, once again, has to do with the fact that this says less than or equal to 0. So we want below the x-axis. This time, though, you're going to use brackets. We're going from negative 3/4 to 1, closed interval, because it wants to know when it's also equal to 0. Okay. And then last one here, and we can talk about graphing inequalities as well. But this one is already in what's called factored form, so there's nothing you really need to do with it. X plus 3 squared, let's fix that, and x plus 1 and x minus 4 is greater than or equal to 0. So I don't need to expand this in any way. I'm just going to set each of these equal to 0 and solve. This gives me negative 3, and it has what's called a multiplicity. We'll talk about that more when we do our polynomials unit. Sorry, I can't write and talk at the same time. So we have these x values, all right? So this number line is going to have points at negative 3, negative 1, and 4. Okay, so we have more intervals this time that we need to check. All right. And this is not just a quadratic. I know that most of this is, but plugging in values less than negative 3 results in negative, and I'm not doing these out, just trust me here, results in a negative number. In between 3 and negative 1 results in positive. Something in between negative 1 and 4, like 0, result in a negative, and then this results in a positive. Now, don't get ahead of yourself and start shading those negative sections. This one is looking for greater than or equal to 0. So we actually need positive values. And so we're going to shade here, our positive intervals. So from there to there, and then from there to forever. Okay. So our interval here, where it is greater than or equal to 0, is from -3 to -1. It dips below the line from here to here, and then picks back up at 4 and goes infinitely to the right. Okay, so that is boundaries and intervals of quadratics. Also be able to graph quadratic inequalities. And that just goes into knowing if you're plotting this quadratic, where to shade in terms of above or below the line, whether the line is solid or dashed. That's a prerequisite. If you'd like some additional examples of that, then please let me know.